Hello, my name is Yasser Al-Mashad. I work for F5 as a regional solution architect. In this video, we will talk about how to integrate F5 Big IP and NGINX solutions with VMware Tanzu. So VMware Tanzu, they use Antrea CNI. And just to give an overview about CNI, it's standard for Container Network Interface. It's a networking plugin for Kubernetes. As you know, Kubernetes does not come by default with networking model, but it allows you to use the networking model of your choice through the CNI. In this case, VMware Tanzu is standardized on the Antrea CNI, and F5 we built an integration with that. So the Big IP is an external ingress, it's an external load balancer, while NGINX is an internal ingress controller inside Kubernetes. When it comes to the external load balancer, the support for CNI is important because it is required to allow the external load balancer to reach the resources inside Kubernetes. But for the internal ingress controllers like NGINX, it does not matter which CNI you are using. So we'll talk about both the integration of the Big IP, and then at the end we'll cover also how to use NGINX ingress controller in the same solution. So let's talk about the two common approach of integrating an external load balancer like Big IP with your Kubernetes. The most common one is the node port. The node port, the deployed application inside Kubernetes, is going to be exposed in every single node in the cluster. So the number of the pool members on the external load balancer will always equal to the number of the nodes and not to the port. This is because the external load balancer does not have a direct access to the pods. So the application pods might be more or less than the number of the nodes, but the external load balancer does not have clue about those. So it only communicates with the node, and then there is another layer of proxy, which is the kube proxy, that will receive this traffic, and then it will send it to the relevant application pod inside the cluster, which might be on the same node or on a different node. That's why some of the disadvantages in this mode is that there could be lots of unnecessary east-west traffic. It might also be slower from networking perspective because there is additional hop here, which is the kube proxy. It also, some of the advanced traffic management capabilities are not possible, like session persistence or advanced load balancing or health monitoring. But one advantage of this mode is that it's easy of use and that it's applicable to any CNIs used. In fact, it does not matter which CNI that you're using inside Kubernetes, the external load balancer in a node port always will be able to work. The next mode is the cluster IP mode. In this mode, the external load balancer like Big IP, it will integrate with the Kubernetes networking. So it will participate with the networking. It will join the Kubernetes networking as a node by building the necessary tunneling, the VXLAN tunnels. And once that is done, then the Big IP will be able to reach these pods directly. So this is, of course, a much better approach. It will eliminate the east-west traffic. It also allows the Big IP to reach these pods directly by passing the kube proxy, so it's better from networking perspective. And it also allows the use of all the advanced traffic management capabilities. The only disadvantage of this mode is let's say, the complexity that there are some configurations need to be done in the networking part to build the VXLAN tunnels and to configure this, to configure the relevant Kubernetes networking accordingly. And then with Antrea CNI, they introduce a special mode which is called Node Port Local. In the Node Port Local, which today only work on the Antrea CNI, basically it allows the applications deployed inside Kubernetes to be exposed only on the node that they are running on and not on the all nodes as in the node port mode. And this allows the external load balancer to reach these pods directly by passing the kube proxy and also eliminate the east-west traffic, and it will allow you to use the advanced traffic management capability. So it have all the advantages that is available in the cluster IP mode. But at the same time, it's very easy to use and deploy. It does not require to configure any VXLAN tunnels or any networking for Kubernetes. So it have the best of both. It have the ease of use and deployment as a node port. At the same time, it have all the advanced capabilities of the cluster IP. And then let's just cover quickly how BigIP integrates with Kubernetes. So BigIP is always sit outside the cluster as the external load balancer. It can be a virtual machine or a hardware. And then there is another piece of software which is called CIS, standing for Container Ingress Service, that's deployed as a pod inside the Kubernetes. And this agent is responsible to watch the Kube API calls. And then whenever the Kubernetes admin try to publish an application by creating an ingress resource, it will detect that, and then it will convert this to a configuration on a BigIP. All right, so it will be able to allow you to publish the applications on the BigIP automatically as soon you commit any ingress resources inside the Kubernetes cluster. So with that, let's jump in the demo. So I have a Kubernetes cluster that have Antrea CNI deployed. Let's validate that. So we can see that the Antrea agent are deployed. There is one agent per node, and there is the Antrea controller. Let's check the health of the node. So they are all in ready state, which means the networking is up and running. All right, so let's now deploy the CIS component. So the CIS, as we mentioned, is the agent that will be deployed inside the cluster, and it will communicate with the BigIP to create the relevant objects. That's why it needs to have the credentials of your BigIP and the information of the network information for BigIP. Now, I have to specify the partition on BigIP where I'm going to create the resources. And in my BigIP, I have already created this partition. All right, so this is where the resource is going to be created. I also need to specify custom resource definition because I will be using the virtual server object, which is a custom API created by F5, which we encourage you to use it instead of the ingress, because ingress that come by default with Kubernetes is very limited in its functionalities. But as you know, BigIP have lots of advanced features, and we have exposed these features in our custom API. But the most important argument here is the pool member type equal to node port local, and this is what's going to enable the integration with the Antrea CNI. So let me create the CIS. And then let's check if it is deployed successfully. So we can see it's up and running since a few seconds, so all good. Next is we're going to create the demo application. So I have here a demo application. It's a normal application that have a deployment and the service. And the service, of course, is cluster IP. It's not exposed on the node because our Antrea integration will allow the external load balancer to reach these pods internally. However, the most important piece here is this annotation that we need to apply on the service. All right, so we need to enable the node port local, enable equal true. So this is important. And once we do this, the Antrea agent will detect that, and then it will create the necessary configuration on the pod to allow the external load balancer to reach to that pod. So let's create our application. And then let's verify if the annotation was created by Antrea node. So let's query the pod of my demo application. And if you notice here, there is one annotation that was added automatically. It includes some of the information about this pod. And this is basically the information that the external load balancer will look for in order to be able to reach this pod directly from outside. So everything is good. If you see this, which means so far so good, Antrea CNI is working as expected. The last piece is, of course, to create the virtual server resource, which will publish this application on the BigIP. And this is my virtual server. It's a custom API, as you can see, publishing this application with this host name. And this will be the IP address of my virtual server on the BigIP. And everything else here is optional. I can apply the persistence profiles. I can do the health monitoring, the load balancing. This is what I meant by the advanced capabilities of the BigIP that we expose in our custom resource. We also optionally can also apply the security policies like bot protection policy, DDoS policy, and the WAF. But these modules are not enabled on the BigIP right now in my lab. That's why I have them disabled. So let's create the virtual server. And let's go to BigIP and check if the objects were created. So if I refresh this page, I should see my application now up and running. And if I go to the pools, I should see the pool created, and the pool member will be equal to the number of the pods inside my Kubernetes. It will be equal to the number of the application pods, not the node. In fact, if I scale this application, and let me do that right now. So let me scale this deployment to, let's say, 5 replica. And then let me check if they were scaled successfully. Yes, you can see that there are 3 pods just created right now. Now, if I go back to Big IP and refresh the pool members, I should see 5 pool members listed here. Now, the IP address is always going to refer to the node IP address, but the ports are unique per pod. These are different ports per pod because the Big IP is communicating with these pods directly. And all of that's possible without setting up any VXLAN tunnels or advanced networking configuration. Now let me try to access this application from outside. And I can see the application is up and running. All right, so the client is able to go to the Big IP. The Big IP is then able to communicate with the application inside the cluster. All right, the next thing is that let's try now to deploy the NGINX. All right, so what we're going to do next is that we're going to deploy NGINX ingress controller inside Kubernetes cluster. So we will have 2 layers of ingress. We have the external Big IP and we will have the ingress controller. So let's go and deploy the NGINX ingress controller. And first thing, let me delete that virtual server that I created. So this should remove the configuration from the Big IP. Because what I'm going to do now, I need the traffic to go first to the Big IP, and then I need Big IP to send this traffic to the NGINX ingress controller that's deployed inside the Kubernetes cluster. And then the NGINX ingress controller will send it to the application that's also running inside the cluster. All right. So first thing, we need to have the repos. I'm going to use Helm to install the NGINX ingress controller. So just add the repo for NGINX, make sure it's updated, and then create the namespace, and then just deploy. So I'm going to deploy the NGINX ingress controller, the normal free version. I'm using a specific version that's compatible with my Kubernetes cluster. I'm going to deploy it in this namespace, and then I give it a name and the service type is cluster IP. Remember that the external load balancer have the Antrea integration, so it will be able to reach to that internal ingress controller. I don't need to expose it on the node port. Looks good. So let's check if everything is fine. So I can see the NGINX ingress controller pod and the service, and everything looks fine. Okay. So the next thing is that we need to create the annotation on the NGINX ingress. Remember that in order for the external load balancer to reach that internal service, we need to have the annotation applied to the service. So for now, if I try to query the pod of my NGINX ingress controller, I see that it's missing the annotation, that the node port local annotation, which have the information necessary for the external load balancer. So let me annotate the service of the NGINX ingress controller. And once I annotate the service, the Antrea agent will automatically detect that, and it will create the necessary annotation on the pod. So if I query the pod of the NGINX ingress controller again, now I can see this information were added automatically, and this will allow the external load balancer like Big IP to reach this pod directly. All right, so now let me create a demo application. first let me delete the one which is already were applied, and then let me create this new demo application. Now, why did I delete that and created that? Very simply, it's the same demo application. All right, so if I go here, this is a demo application. It's the same one. The only thing I did is that I removed the annotation from each service, because remember, in the previous demo, Big IP was communicating directly with the service. In this demo, I do not want the Big IP to communicate directly with the service. Instead, I want the Big IP to communicate with the NGINX ingress controller, and then NGINX ingress controller then will communicate with the service. So I have two point of controls for my traffic. All right, so my demo application is deployed. And next, I need to publish this application first on the NGINX. So I will create the NGINX virtual server. So if I look at here, this is the normal. It's another virtual server, but this is from the NGINX. This is the NGINX API. It's also custom resource definition. It's a very basic one. I only publish that application, but NGINX ingress controller has so much advanced capabilities. I encourage you to check the documentation or maybe watch my other videos where I explain the advanced features of the NGINX ingress controller. In this case, I'm just going to publish the service. And then next, I need to publish it on the external load balancer. All right. So again, I have another virtual server here, but in this case, this virtual server is CIS virtual server. This is the Big IP virtual server that was going to publish this application on my external load balancer. I can use wildcard here, so I can have a single virtual server or single VIP on the Big IP that publish many different applications that are running inside Kubernetes. And on the NGINX, I can have also several different virtual server, one per each application. So I have more flexibility here. Now, most importantly, if you notice here that the service that I'm sending the traffic to is the NGINX ingress controller service, okay, and not the application. So let me create that. And now let me go back to Big IP and check if everything is fine. So everything is good. You can see that the listener was created. And if I go to the pool, I should find the pool created also. And this pool is referred to the NGINX ingress controller. If I check the pool members inside this pool, I should see the ingress controller pods I mentioned here. Now, because I deployed my NGINX ingress controller as a one single replica, this is the only one replicated here. But if I scale out the NGINX ingress controller pods, because maybe I need to scale for an increased number of the users or the number of the traffic, this will be also automatically reflected here. All right. Now let me try to test if I can access this application. Of course, this will not work. I have another one here. So this one to work fine. So this is an external client. He tried to access this application, which basically resolved to the virtual server IP on the Big IP. Big IP received the traffic and then send it to the NGINX, and then NGINX check its own virtual server, and then it's able to direct the traffic to the application. All right. And with that, this concludes my demo. I hope it was useful, and thank you for watching.